Hello! In this lecture, we'll take a look at what we've learned so far about data science fundamentals, linear algebra, statistics, and probability. And we'll look at how to visualize these concepts using a Python plotting library called matplotlib. This lecture will bring back some new concepts in Python with the introduction of a new library, similar to the NumPy library that we saw before and gave us the NumPy array. Matplotlib library gives us a suite of plotting and visualization tools to compete with Excel. Data visualization is one of, if not the most important method of communicating data science results. It's analogous to writing. If you can't visualize your results, you'll be hard-pressed to convince anyone else of them. But visualizing is not just used for generating figures for papers or reports. It's really more than that. Visualizing is key to exploring data and developing an intuition for it. With plotting, you can explore your data to get a feel for how it looks and behaves, and generally trying to understand what's happening. Matplotlib is a great library in Python that gives us more control over the finer details of how a chart or graph looks. Let's play around with this library a bit.
Let's open a new notebook and we'll write the usual import lines. First, the magic matplotlib inline, so it will draw on the notebook instead of plotting in a new window. Then, import numpy as np and import matplotlib.pyplot as plt. Now let's create some data. X is numpy.linspace from -5 to 5 with 100 data points, and y1 is np sine of x. So we plot plt.plotx and y1. Note that we don't have a legend here. By default, matplotlib won't generate legends, so we will now create a plot with a legend. plt.plotx and y1, and now we need to give this line an appropriate label. The label is sine x. And now we'll say plt.legend. We have to give each plotted line a label so matplotlib will know how to show the legend. We also use plt.legend to draw the legend, and remember that by default, plt functions always work on the latest generated plot. We can plot more than one plot on the same chart, so let's copy the code from above and add another plot into it. We create some new data called y2, which is cosine of x. We'll add plt.plotx and y2, and the label is cosine of x. And now I have two lines on the same plot. We can also plot two plots side by side. The subplot command lets us specify the topology of how many rows and columns we'd like. We're going to have one row with two columns, meaning that the two plots are beside one another. So first we say we want plt.subplots 1 and 2 and the first plot for now. And then plt.plotx and np sine of x, and the label is sine x. Now we'll get to the second plot. plt.subplot 1 and 2 is the same topology, but now we want the second chart. And then we'll plot the second graph. plt.plot with x and y2, and the label is of course cosine of x. And now we have got two charts showing. In matplotlib, figure is the image that holds several charts together, and each chart is called an axis.
Here I'm going to show you some examples for drawing these plots. First statement, percentage sign matplotlib inline means that just show us this graph here in this Jupyter notebook. Don't open another window for us. And then we are importing matplotlib.pyplot as plt, so we're going to use plt to call the functions. And then we have numpy as np. We call this library just to generate some random numbers. So we have some random numbers for x-axis and y-axis that you can see. all this here. So when I run this, you can see this plot with different values. So each time, because it's random, it creates some, generates some other numbers, and you can see a different plot. Next one, I don't import this matplotlib pyplot as plt. We already done that, so we call this one. So when I call plt.plot, this plot function, and then I have some numbers by np.array, and then we have these values. Marker O means just present these values, mark these values by O. What if I just assign an asterisk? Let's see. And then make means the color of this marker, which is red. Now, when I run this, you can see how this plot changes to this. So now, do you see the result? If I change it to O, and then if I change this one to green, let's see if it changes. Oh, sorry, that was small O. Okay, now you can see that all these are green, and then if I turn it back to red, we can see this red ones. All right, next one, we have points NP array with these values that we have 3, 8, 1, and 10, and then we have we're calling plot function yPoint. The color of the graph, this line is green, and then the width of this line is 3, and line style is dash dot. That's different kind of style we can assign to each one of these plots. So when I run this one, you can see the result. What if I change this to red? You can see how it changes. And if I change this one, like this is 3, what if I put 6? You can see how the width of this line changes. Line style is dash dot. What if I say dotted? And then you can see how it changes the style of this plot. You can just play with this line. I recommend you to run this code and give different arguments to each one of these parameters. All right, the next one, this is another one, x and y values with these two arrays, and then we are calling plot scatter function. This one draws a scatter plot for us, and then we have another values, another arrays here for x and y, and you can see it shows these two plots with different colors by this scatter function. This is another design that depends on the values and the data and how we want to show those data. All right, now here we have another one NP array ABCD, and then it contains another one y, it contains 3, 8, 1, 10. You can see all this. Now we have a y label for this, and we have x labels, that is ABCD here you can see, and then we have we are calling bar function that draws a bar graph for us with this x and y values, and the width is 1.1. If I change this to 0.2, you can see how it changes. And if I just change the color, you can see we can use all those properties here by giving different arguments to our function. Another one is how we can create a pie chart. Now we have these values, and then we have our labels for apple, banana, cherries, and dates, and then what about this one, plot pie? Here we are calling a pie function just to draw a pie chart for ourselves. we have our labels, and then we have this explode, which means this part of the graph should be separate from all this. Another thing we have is calling legend function, just to have a legend for our chart. And then we can assign a title also to this legend, which is for first ends, as you can see, and then that's what we have. What if I exclude this part from my function? Let's see. So as you can see, it doesn't draw that part as a separated part. But again, if I add this one, you can see we can just play with all these functions to draw them differently based on the data that we have and how we want to represent them.